Good morning all. Lipo packs, so lithium ion battery packs, I think they're all 4-cell. Yes, these are typically used for radio control, quadcopters, that sort of thing. The chemistry is almost certainly NMC, nickel, manganese, cobalt, or some such. They're not lithium iron phosphate. Now, I haven't looked at these for several years, could be 3 years, I can't remember. But I thought I'd dig them out and just see what was what. So let's put them on some sort of battery tester. Here's the little BG8S battery tester. I wonder if we can just do it with the main connector. Yeah, that's fine. We're not getting cell voltages, but we are getting a pack voltage, which is 15.69. Fine. Let's put this one on. Now, I've not pushed the plug all the way in, and there's a good reason for that. Oh, that one's a bit lower, 13.64. And let's try this one. Oh, nothing at all. Dead. So here's the story. This one, which is a regular LiPo pack, absolutely fine. Had some charge in it. I charged it up. I used it. These two, which are intelligent batteries with the third wire running up to the XT60, and it actually has a third connector, both completely flat. 0 volts, nothing, well, a few tens of millivolts perhaps. So this one, I recharged very carefully and gingerly, of course, as you would. This one I haven't done yet. So today in this video I thought I'd charge this battery back up from 0 volts and show you the processes I used. Right, first things first, let's get a multimeter on the battery pack and see how many volts we actually have. Make sure this is definitely not in the 10 amp setting, although this is completely flat so it wouldn't really do anything. Okay, volts DC, plug this in. Sorry about the fact that I'm using 2 black wires. But this is the only one I can find with the S on, which means I've soldered it because these are notoriously awful when they're just crimped. So there we are, 96 millivolts across the whole pack. That's all 4 cells, 25 millivolts per cell. So now we need to start charging this battery pack, but I want to do it incredibly gingerly, and I'm going to do it inside to start with because there's no energy in here. If I put a nail through there now, nothing would happen. And until we get to several volts, there just isn't enough energy in here to do any real harm. So let's get that started. And it's actually incredibly easy. You just switch this to diode. There we are. And it starts charging. And that's because when your multimeter is on diode test, it puts a little bit of current around the circuit in order to measure the forward voltage of the diode. Well, that little bit of current flowing is charging the battery pack. So I'm going to leave that running for a bit. I don't think it'll get very high in voltage. I think on the other pack I got to about 1 volt and then it slowed down to a crawl, so I had to switch to another charging technique. But at least it charges this incredibly slowly, and so there's no danger of anything nasty happening. Right, we're just coming up to 1 volt. Now that's 1 volt across the whole pack. So that's only 1/4 of a volt per cell. So I'm still perfectly okay being indoors because there's just not enough energy in here to do any kind of damage. But now we need to do the most important thing of all during this process, and that is to check that all 4 of these cells are coming up in voltage, because if there's a dendrite in any one of these, then that would tend to hold the voltage of that cell at 0 or close to 0. So I'm going to check all 4 cells on the second multimeter by going across them like so. What are we looking for? About 250 millivolts per cell, so that's 200 and something. That one is 250. That one is 280. And that one is 260. So it looks like they're all coming up. Cell 1 looked a bit odd. Let's do that one again. I'm not sure I'm getting a very good connection on there, am I? Okay, we got 220 on there, so I'm not too concerned. Now this is slowing down, and this is not a way to actually start charging this battery. I'm going to need something else. It would take, I'm not sure this would actually go above about 2 volts, because of course it's only intended to measure diode forward voltage drop. So we need to switch to another way of lifting the voltage of this up more quickly. Right, we're up to 1.1 volts. I've switched the second black wire for a green one. So green now denotes positive. Yeah, I know it's still not very good, is it? Right, next step, I'm going to use this 12 volt sealed lead acid battery, and somewhere I have a resistor. Now this one is quite a high value, it's 4K7, but I think that'll be good to start with. So I'm just going to tuck that inside there if I can get it in. Right, so let's move negative of the battery to negative of the battery, like that. Positive of the LiPo will go to the other side of this 4K7, but before I do that, I just want to get some wires in here so that I can see what's going on in terms of voltage. So let's hook that up to the negative. I'll need another wire. I think this white one is sort of working, but there's no S on it. I write S on it when I solder them, and they're really rubbish when they're not soldered. Okay, so the multimeter is hooked up to the lead acid battery. We're seeing the voltage of the lead acid battery, which is 12.9 volts. Let's put the positive of the LiPo now on the far end of the 4K7 resistor, and up we go with a little more pace. We'll see how far this goes. I've got another resistor so that when this slows down, I'm going to switch to this 680 ohm resistor, which should pep things up a bit. But this should take us up to, I don't know, 2-3 volts. So heading up to 2 volts. And once again, the most important thing to check now is that these cells are all coming up in voltage, because we don't want any cells which look like they might have been compromised in the discharge to 0 volts. So that's 0.4, that's 0.4, that's 0.49, and that one is 0.47. So they're all similar voltages. So my guess is that the cells are all good. We just need to keep lifting the voltage of this pack up until it's going to be recognized by some sort of commercial LiPo charger. Right, this is slowed right down at 1.888 volts with the 4K7 resistor, which is a very low value. So now I'm going to switch in the 680 ohms. So 680 ohm resistor in there. Oh, that connection's not terribly good. Once again, I'm looking at the lead acid battery voltage. Okay, let's put the LiPo on. That should push it up a bit more quickly. Yep, there it goes. That's going to hit 3 volts fairly quickly. Now if we can get that to 4 volts, that is at least 1 volt per cell. Might need to go further than that for a lithium-ion battery charger to see it, but let's just see how far it goes with the 680 ohm resistor. One point about using this 12 volt lead acid battery, the final charge voltage of a 4-cell LiPo is something like 16 point something. Well, it's 16.8, isn't it? 4.2 volts per cell. So even if I left this indefinitely, there's no way I could get this pack up to a state of charge that's going to be problematic or stress the battery in any way. So 12 volts is probably quite a good choice to bring a 4-cell pack back up. 3.5 volts. Let's see if we can get it up to 4. That's 1 volt per cell. Right, up to 4 volts now. Now I could at this point again measure the cell voltages, but I'm going to see if I can connect it up to a commercial battery charger, this little ISDT. Again, it was a Banggood, well, freebie, let's say. I did a review on it many years ago. So I'm going to sweep all this away. I don't need the DVM now because this thing has the ability to measure each cell voltage, and I'm going to drive this from that other LiPo which didn't go entirely flat, and so that can be my source, which goes in there, and then my battery to be charged goes in there. Let's set all that up. Right, let's plug in the supply battery, which is that one. This thing powers up. Now let's plug in the battery to be charged and see if it manages it. Oh, that's saying it's a 1 cell. Well, it would, because it's very low voltage. Let's plug in the balance lead. So I want 4S, charge, LiPo, 4.2 volts, 4S. I'm going to set it to 2 amps. It won't charge at 2 amps or anything like it initially, because it will recognize, hopefully, that it's, do you want to perform unbalanced task? Well, let's say yes and see what it does. Battery connection exception. Yes, all right, no, you can't press that. So it's still not at a high enough voltage for this thing to charge it. I've got another one similar to this. Let's try that. Let's try this Q6 Lite, and if it won't do it, then of course we'll have to go back to... I wonder if we could charge this unbalanced, actually. We'll have to go back to the other one. Battery voltage. Oh, that's coming up. I don't know whether that means it's charging, but anyway, let's see what this is. Charge LiPo 4.2 4S, current 0.1. Well, these things normally have a detection if the battery is low. Let's just start that without balance. Yes. Abnormal battery connection. Yes, thank you. So it's not going to do it because the voltage of this isn't high enough. But that's interesting because it was creeping up, wasn't it, when I first plugged it in? So is it doing a thing where it's trying to lift its voltage? I don't know. Well, clearly we're not quite ready to put this on a commercial battery charger yet. They seem to be getting cross. I didn't try all sorts of various combinations of pretending it was a smaller number of cells or something like that. I could have tried that. Yeah, there's all sorts of combinations I could try, but I think I'll just push it a bit further on the lead acid setup and then have another go on one of these ISDTs. In fact, I've decided to have another go with this. I'm going to tell it that it's a LiPo 2S because it should recognize that, but I will put the current right down to 100 milliamps. This thing is on there just because this will work just on the balanced charge lead. So that's going to be my check that the individual cell voltages are all right. So will this work at 0.1 amps 2S? Let's try. It's going to be unbalanced. Yes. 100 milliamps. Oh, and it's doing it. There goes 100 milliamps. Now we've got the output voltage here, 4.3, 4.4. That's now booted up because it's getting enough volts. Although it's a bit erratic at the moment. But we should, when that boots up properly, get some cell voltages. 4.5. Might need to raise the current a bit actually, because I think that's holding it down a bit. So let's go for current 0.2 amps. See if it'll do that. 4.6 here. That's stabilized. So is it going to... We've got a flashing red 0 volts thing there. That must just mean that it's below the operating voltage of this device. But we've got 4.7 volts on the pack now. Charging at 100 milliamps. I'll just leave that for a while. I'm not concerned that this pack's going to burst into flames at this stage. I'm really waiting for this thing, which always the display times out on this. It's really irritating. To give me some cell voltages, but it presumably won't do that until it's seeing enough voltage that it's happy that it's a lithium type battery. 5.6 volts across the whole pack. Right, by unplugging this and plugging it back in a couple of times, it's now showing voltages. Can you see that? Just about. They're all red because they're all low, but they're all 1.8, 1.7. Cell 1 is a bit higher than the others, but this device can balance as well, but I really just want to get to a situation. Stop switching off. No, I don't want that back. To a situation where I can plug the balance lead into this charger, and this charger can do everything on its own. I think we need to go a bit further than 7.4 volts though. This is now up at 0.2 amps, so I could probably bring that back down to 0.1 and do this at the slowest possible rate, which is less likely to cause trouble. Now, having set this to a 2S, that's not going to go much beyond 8 volts. 8.4 will be the top. So I should probably stop it and tell it now that it's a 3S. Still 0.1 amps. Start that. Yes, I wanted it unbalanced. It's saying that because the balance lead's not plugged into this device. The pack is now down to 4.5 volts. Yeah, I think this is putting a heavy load on it when it's constantly rebooting. So let's take that off for a minute. Get this back up to a suitable voltage. It had got up to 8 volts, hadn't it? So let's get it back up to 8 volts and then plug that in and see where we go from there. So I'm now going to leave this for a while. I can see that all the cell voltages are coming up. There are no obvious problematic cells. This is currently set to 3S, I think, but it doesn't really matter. It's on 100 milliamps, so it's going to take a long time. I'll come back when we're ready to start bumping up the current and charge this like a proper LiPo. Now, even though I've set this thing to 0.5 amps, half an amp, it doesn't actually run at half an amp because it realizes that the cell pack is very low. This is now set to a 4S, so that's the proper setting for this pack. So it will continue to push 100 milliamps into there until it recognizes that the pack voltage is up to, well, I think 3 volts per cell would be realistic. So this needs to be about 12 volts, I think, and then this should then rise up to the higher current and we start charging this at the proper rate, at which point I suppose I might take this outside so that if it does burst into flames, it doesn't do it in my house. Right, I've managed to find a setting on here which is the low voltage alarm, and I've set that to 2.5, which would be more appropriate for, say, lithium iron phosphate. I know this isn't an iron phosphate, but I just got fed up with the alarm sound. So 2.5 on that, back. And so the first cell, which does seem to be leaping ahead a bit, is over 2.5. That's not showing in red. The other three are still under 2.5, so they're showing in red. So that's probably better for this, because I really want this thing to not be in an alarm state. 9.6 volts. This is still running at 0.1, even though I think it's set for 0.5. Let's have a quick look. Yes, it is set for 0.5, so let's go back and just leave it and wait for this to go up to about 12 volts. Actually, because I'm just bored and want things to do, perhaps I'll take that off there and put this into the actual charger now. Okay, it's not a touch screen, Julian, so you've got to press that. Okay, so now let's just do a regular charged LiPo, 4.2 4S, half an amp, start. It can now see the voltages on the balanced charge lead, and so yes, it's running at, so I don't need this thing anymore. It's running at a 100 milliamp current, even though I've asked it for a half amp charge, and of course it will stay at that until it sees some sensible voltages on all of the cells. Then it will rise up to half an amp. I'll take it outside, and then it will balance at the top and bring all the cells to the same voltage, one would hope. Just got some interesting screens on here. We've got the cell voltages there. Interestingly, it's saying that the pack is 0% charged, presumably because at 3 volts per cell, it assumes that's about the minimum. If I scroll the wheel, we've got the internal resistances. It's not calculating those yet until the cell voltages are at something it can work with. It's showing me that the input pack, this one, is at 15.5 volts. That's still got some juice in it. The output pack, this one is now at 10 volts, so 2.5 volts per cell. 2 watts is the power coming in, and only 1 watt going out. Yes, I suppose this could be burning 1 watt. It's actually quite warm. So yeah, it could be eating up 1 watt within its own circuitry. It's losing quite a bit as heat. But yeah, some useful information on there. Still at 100 milliamps though. I found this neat little cell monitor thing which I've put on the source pack just to keep an eye on it. All the cells on there are exactly the same voltage, 3.87. But we're now at the point where this is 3.1 on cell 1, 3.02 on these 2 cells, and just 2.97 on cell 3. So I think when that gets to 3 volts, I'm guessing that's the point at which this will ramp the current up to start doing a proper charge. It's still saying 0%. Once it does start running at the higher charge rate, I am going to ship this all outside, and I've got a glass table out on the patio, so I'll put it on that, just because the amount of energy in here is now starting to become significant. I mean, it doesn't show any signs of problems, and although you can't see it very well, the cell voltages are all reasonably imbalanced. Cell 1 seems to have gone ahead of the others a little bit, but that should, now that it's 3 volts on all, can you see that? You can't really. Perhaps you can see it better there. 3 volts on all of the, oh yes, that's gone to 0.5 amp. Right, moving it outside. Right, I've put it on this glass table on the patio, just in case there are any problems. I don't anticipate any. Can we see that? So yes, that's going up quite rapidly now that it's at 0.5 amp. 3.4 volts per cell. It says that the pack is at 14% state of charge. I was just going to see whether I can find a thing to take it to 4.1 volts rather than 4.2. I'll have a quick look. Yeah, here we are, look, we've got Lipo 4.2 and lithium ion 4.1. So maybe I'll set it to lithium ion 4.1 so it doesn't go quite as high. Yeah, I think I'll do that. And now I'm just going to leave it here and probably forget about it, and so come back when it's done, so see you a bit later. Right, I've stopped this charge. I don't see there's any sense really in charging this right up to 4.1 volts. I haven't really got a use for it. The cell voltages at the moment are 3.85 or 6. Actually, I can't remember which one was high, but cell 1 is now fractionally lower than the others. But I'll just take it inside and hook it up to a BattGo compatible device, just to show what BattGo actually is. So this little BG8S balancer is BattGo compatible. So if I plug that in, now if I only plug it in part way, it tells you the pack voltage, but it can't tell you the cell voltages because I haven't connected the balance lead. But if I plug that in all the way, that third terminal connects up, and it can now tell you that it's a Charsoon battery, which it is. It was made in 2017. It's a Lipo 4S. It's 1300 milliamp hours. Yes, it is. It can be charged at 5C, discharged at 80C. What else have we got here? It tells you the number of cycles. 1 cycle, 1 alarm, 1 charge and 1 discharge. Is there any more information? Yes, it gives you actually all the cell voltages, funnily enough, to 2 decimal places. And those voltages are being measured by the microcontroller in the battery and sent out as a digital data stream on that third pin. Now if I connect the balanced charge lead, it actually gives you the battery cell voltages to 3 decimal places. And now what it's doing is it's actually, this device is measuring them on the balanced charge lead. So there is going to be a discrepancy between what you see here and what you see if you take that out and rely on the measurements coming from this battery. There are some other things you can do. You can press and hold that, I think. You can go into here and you can actually write into the little memory chip in here what its end voltage is. Now, of course, this is only relevant if you connect this to a BattGo compatible charger. but you can tell it that instead of charging to 4.2 volts, we want to charge it to, I think this only goes between 4.1 and 4.2, but you could say charge this to 4.15 volts, and if I go back, then it writes that into the battery. So if you connect this to a BattGo compatible charger, it'll charge it to 4.15 volts instead of 4.2. And it does some quite clever stuff. But is BattGo still a thing? I mean, are you a radio control enthusiast? Did you ever use BattGo packs? Is it still something that people are using? So there we are, both the smart Charsoon BattGo compatible batteries are now charged and ready to use. But I'm going to have to keep an eye on these because I think I read that the standby current of the little chip in here is 50 microamps. But if you leave these for a couple of years, when you come back to them, they will be completely flat. Cheerio.